9.2, verifying trig equations. Well, this one's very similar to what we did on 9.1, but on 9.1 we just kind of started simplifying down till we could get to something in kind of a much simpler looking form. Well, on this one, we're going to be told one does it equal the other one, and we have to verify yes it's true or no it's not true. So the guidelines we give you for these say basically you're going to pick one side or the other, and you're going to work one side and try to make it match up to the other side. If you can get there, it's true. If you can't, it's not true. It's false. So we're just trying to verify, and we gave you some hints on some of these to work which side to start with. So like, whoops, I don't know where it just went to. So let me try it. Okay, so sometimes things to do is look for usually the more complicated side. Like, don't just give up. Just pick one side and start working with it. If one side looks way too easy, like I'm looking at number 1 and number 2, these are single terms, so those are usually almost too easy, even though we have equivalency, so we could start with those sides. But what I would probably do is start with the other side. So on number 1, the goal is, can we make the left side simplify down to the right side? So I see a fraction with a single denominator. So my advice would be to, let's split that apart. So I'm going to work with the left side on this one. Secant squared theta minus, well, I'm going to put that over secant squared theta, and then minus 1 over secant squared theta. So it's the same denominator, so I can split it apart. And secant squared over secant squared is 1, minus 1 over secant squared. 1 over secant squared is cosine squared, and I'm using theta, not x. So 1 minus cosine squared, if you remember from your Pythagorean identities, is sine squared. And now the left side equals the right side. So yes, this one is true. So yes, is it true or false? So true on that one. The whole right side was always sine squared. We never touched the right side. Sine squared. Sine squared. I'd almost put an x and not a theta. So sine squared equals sine squared. So yes, this one was true. So let's look at number 2. In number 2, I'm going to bring up a Pythagorean, the identities page, just so we have that available. So give me just a second. Let me hit pause and I'll be right back. Okay, I'm back, and you probably didn't even know I was gone. But on number 2, I'm going to work with the left side. Looks more complicated, so I'm going to work with the left side. And one of the things we did when you see a denominator that looks very similar to each other, I'm going to go for a common denominator. So I'm going to multiply by 1 plus sine of x on the first term over 1 plus sine of x. That's multiplying by 1. And on this one, I'm going to multiply by 1 minus sine of x. It already has the plus, it needs the minus. So 1 minus sine of x. So the numerator just becomes 1 plus sine of x for the first term. The denominator now is 1 times 1 is 1. And when it's a difference of 2 squares, you don't have to worry about the middle one because you're going to get a negative sign and a positive sign. So 1 minus sine squared. And they both have that same denominator now. So plus, and now this would just be 1 times 1 minus sine of x is 1 minus sine of x. So the right side is still 2 cosecant squared. I didn't touch the right side. So now, if I look on like terms on the top, I have 1 plus 1 is 2. Sine minus sine is not anything. And 1 minus sine squared, if you need to see it, 1 minus sine squared is cosine squared. So that is 2 over cosine squared x. Does that equal 2 cosecant squared x? Well, 2 over cosine, the reciprocal cosine is secant. So 2 secant squared x does not equal 2 cosecant squared x. So this one is false. The left side did not match the right side. So your assignment is a lot of true-false, but it's because we're just verifying, do these identities equal each other? So that is the front side. So let's go to number 3. And on this one, my advice would be I would work the right side on. The right side looks more complicated than the left side. So if I were giving a hint, I would start with the right side. And I would probably FOIL first. I'm looking to see. Oh, maybe not. We looked at what Miss Whitcamp did, and she did something besides foiling. Well, she said tangent squared plus 1 that was on our tangent squared plus 1 is just secant squared. So she wrote that, and I like that idea. So we have the left side I'm not touching, so it's negative tangent squared x equals, the first parentheses would be secant squared, because tangent squared plus 1 is secant squared. Well, cosine squared minus 1, cosine squared minus 1 is just opposite signs of these. So it is negative of 1 minus cosine squared, so it's negative sine squared. So that is negative sine squared. I don't know if I wanted to do that or not. Negative sine squared. Did she do that? She did. And then she said, let's rewrite, well, the left side I'm not touching. I'm leaving it alone. We only work with one side only. So this secant squared is 1 over cosine squared. And that's negative sine squared. And if we write it as a fraction, it's over 1. So this is negative sine squared over cosine squared. So almost forgot my x, which is left side's negative tangent squared, and hopefully you remember that sine over cosine is tangent, and they're both squared, so it's tangent squared, and there was a negative in front. So did these verify? Negative tangent squared x equals, so yes, this one is true. And number 4, you could actually work with either side on number 4, but I'm going to go with the left side. Because I'm like, oh, let's try to change addition and multiplication. So I'm going to rewrite tangent as, I like putting things in terms of sine and cosine. So tangent is sine over cosine. And cotangent is cosine over sine. Okay, and we didn't touch the right side. It's still sine times cosine. Well, let's go for a common denominator. So if I multiply by, that one has sine, so I'm going to multiply by cosine on top and bottom in the numerator and denominator. And this one has cosine, so I'm going to multiply by sine in the numerator and denominator. So I end up with, on the first one, I'm going to have sine squared. In this one, I'll have plus cosine squared. And both denominators are sine times cosine, so I only have to write the denominator once. Sine times cosine. And does that equal sine times cosine? Well, this, do you remember sine squared plus cosine squared? Hopefully you remember the main one of the Pythagorean identity. Sine squared plus cosine squared is 1. So this is 1 over sine of x times cosine of x, which is the same thing as 1 over sine of x times 1 over cosine of x, which is 1 over sine, is the reciprocal of sine is cosecant. The reciprocal of cosine is sine. No, sorry. The reciprocal of cosine is secant. I picked the wrong S letter. My mind's jumping ahead and trying to think, can I make this equal to sine times cosine? Well, no. It's the reciprocals of sine over cosine, but it does not equal sine over cosine. So this one is false. They do not equal each other. Okay. On number 5. I'm looking at that one, and the left side we could work with, but I see us just a denominator on the right, and I would much rather try to get a common denominator. So I would multiply by the conjugate. And the conjugate of 1 minus sine is 1 plus sine. And we're using y instead of x this time. And if I multiply the denominator by it, I also have to multiply the numerator by it, or else I couldn't do that, because we're multiplying by 1. So the left side, not touching. It's secant y plus tangent y. And it stays like that the entire time. On the right side, I'm going to distribute, and so that is cosine of y plus sine of y times cosine of y. Did that help me any? I don't know yet. Not yet. But the denominator is 1 times 1 is 1. Then we have a positive sign and negative sign. The middle terms go away, so minus sine squared. 1 minus sine squared. And I'm just going to leave this equal sign here and show that the left side I'm not touching. The numerator I didn't do anything with yet. Cosine of y plus sine of y times cosine of y. But hopefully you remember the denominator, 1 minus sine squared, is cosine squared. And since they both have a cosine, I can divide a cosine away from every single term. It's the same thing as if I had split this apart. That's cosine of y over cosine squared y plus sine of y over times cosine of y over cosine squared y. And I can divide out one of my cosines, which leaves me 1 over cosine. Plus, I can divide out one of them and that one, and so I end up with sine over cosine. And 1 over cosine is secant. And sine over cosine is tangent. So secant plus tangent equals secant plus tangent. So this one is true. We made the left side equal the right side. Last one. I'm looking at number 6, and I'm going, which one? What could we do? And part of me sees a common factor here. So I'm going to try working with the right side. Let's see. If we work with the right side and factor out that greatest common factor. So the left side I'm not touching. It's cosecant to the 4th of x times cotangent of x. You pick one side, no touching. So this one is cosecant squared is already factored out. But I'm also going to divide out a cotangent. And if I divide out a cotangent, cotangent divided by cotangent will be 1. And cotangent cubed divided out a cotangent will be cotangent squared. And 1 plus cotangent squared. 1 plus cotangent squared is cosecant squared. So that parentheses is just cosecant squared. And now I've got a cosecant squared and cotangent times cosecant squared. So we got 3 terms. And if you remember, just for simple math, 2 times 3 times 4 is the same thing as 2 times 4 times 3. It doesn't matter which 2 you put together, but that you can multiply and make that 8 times 3 or 6 times 4. You're going to get the same answer. Multiplication is commutative. So this is cosecant squared times cosecant squared, which is cosecant to the 4th times cotangent. And if you look, that's exactly what we wanted it to be. The left side equals the right side, so this one is true. So, like I said, all you've got to do on these is you figure out where to start, and you just pick one side and start going. And there were many times of these when I would start them, and I would be getting to a dead end, and I'd have to start, and I sometimes would switch and try the other side. On these, I knew what I was doing, so I left it blank for you. So, sorry, I didn't mean to clear off everything. Undo. Whoops. Oh crap, it just closed out. But okay, well, luckily I was through with the video, so that is all I needed from you. So good luck to you, and hope you do well on this assignment.